Hi, everybody. It's Professor Mitchell. Today we are starting Chapter 6 on ratio, proportion, and percent, starting with Section 6.1 on ratio and proportion. In this section, we're going to write ratios as fractions, solve proportions, and then solve problems modeled by proportions. So when we talk about a ratio, we're talking about the quotient of two quantities. And you see three different ways that that quotient can be written. It can be written 1 to 2, or as a fraction 1/2, or with a colon, and that colon is read 2. So this expression here would still be read 1 to 2. You see it written that way when we talk about odds, like odds at a casino are often written like that. So to write a ratio as a fraction, just remember that the order of the quantities is important when writing ratios. To write a ratio as a fraction, write the first number of the ratio as the numerator and the second number as the denominator. All right, so here is the official definition of a ratio, written in terms of the alphabet, just like you saw in the last slide. Okay, so if you had the ratio $25 to $15 and we wanted to write that as a fraction in simplest form, we would start off by writing $25 over $15. And then we can ignore the dollar sign because it's the same on the top and the bottom. You're going to see another example of that here in just a minute. So now it's like simplifying the fraction 25 over 15. They have a common factor 5. You cancel that 5 and you're left with 5/3. All right, to write the ratio 15 to 23 using fractional notation, that's actually a lot easier because 15 over 23 is already in simplest form. So that's all we have to do. Now, if either of your numbers in your ratio happens to be a decimal, fractions in simplest form should not include decimals. So what we're going to do is start off by writing 2 6/10 over 3 1/10. And then I'm saying that the value of that ratio will not change if I multiply it by 1. And the reason I'm pointing that out is because I'm about to multiply the top and the bottom by 10. Remember from the last chapter that when you multiply a decimal by 10, it moves the decimal point one place to the right. So that's how I'm going to turn these numbers into integers. By multiplying them both by 10, I get 26 over 31. That has the same value as the ratio 2 6/10 to 3 1/10. All right, here's a little application problem. Given the rectangle shown, first they want me to find the ratio of its width to its length. Notice the order there. And they want me to find the ratio of its length to its perimeter. So the width of this rectangle is 5 feet, the length is 7 feet. Remember that order is important. So when we say the width to the length, we have to put 5 feet over 7 feet. We would not put 7 feet over 5 feet. That is a different ratio. So just like in the money problem earlier, when you have the same units on the top and the bottom, you can remove those units from the top and the bottom. It's sort of like canceling them out. So the ratio of the width to the length of this rectangle is 5 to 7, or 5/7. To find the ratio of the length to the perimeter, first we have to calculate the perimeter. So remember that the perimeter of any shape is just the sum of all the sides, the lengths of all the sides. The perimeter of this rectangle is 24 feet. So to do the ratio of the length to the perimeter, the length is 7 feet, the perimeter is 24 feet. That ratio is going to be 7/24. All right, that brings us to proportions. A proportion So a ratio is an expression. A proportion is an equation. A proportion is a statement that says that two ratios or rates are equal. And a rate is just a specific type of ratio. For example, 5/6 equals 10/12 is an example of a proportion. And the way that you can read this is 5 is to 6 as 10 is to 12. All right, so we can use that to solve for an unknown quantity in a proportion. In this problem, they want me to find the value of the unknown number n. So remember from chapter 4 on fractions that one way to tell whether or not two fractions are equivalent is to cross multiply. So that's how we're going to do this. We're going to do 51 times n, and that's going to equal 34 times 3. All right, 51 times n equals 34 times 3. 34 times 3 is 102. And if 51n equals 102, we divide both sides by 51. And we get n equals 102 over 51, which simplifies to 2. So the unknown number n in this problem is 2. All right, this one is a little fancier. They want me to solve for y in the proportion 2y plus 1 is to 7 as y minus 3 is to 5. So again, we're going to cross multiply. 7 times y minus 3, notice that the y minus 3 has to go in parentheses, is going to equal 5 times 2y plus 1. 2y plus 1 also goes in parentheses. So this is the type of equation that we learned how to solve in chapter 3, and it came up also in chapters 4 and 5. First thing we're going to do is distribute the 7 and the 5. 7 times y is 7y. 7 times 3 is 21. 5 times 2y is 10y. 5 times 1 is 5. All right, so let's see what they did next. I might want to show a little more work in this step. Okay, yes. So what they've done here is they have subtracted 7y from both sides. So they've decided this time to put the variable terms on the right side. Remember, it doesn't matter as long as you put the variable terms on one side and put the constant terms on the other side. Okay. So the 7y's are going to disappear on this side, and that's going to leave me with negative 21 equals 3y plus 5. Now, since I put the variable terms on the right side, I have to put the constant terms on the left side. So now I'm going to go minus 5, minus 5. And that is going to give me negative 26 equals 3y. I'm going to divide both sides by 3. And that's going to give me y equals negative 26 thirds. Remember that equations can always be checked. This one would be kind of a pain to check. So I'll let you in on a little secret. If you if you don't want to deal with that fraction, negative 26 thirds, you can ask your calculator to give you an approximate value for negative 26 thirds, which would be about negative 8 67/100. And you might find that a little easier to plug into the left side and the right side of this original equation. Now, because negative 8 67/100 is an approximated value for negative 26 thirds, the left side and the right side will not come out to be exactly equal, but they should come out to be very, very, very close, like within 1 or 2 hundredths probably. All right. So that brings us to this application problem. On an architect's blueprint, 1 inch corresponds, to 4 feet. How long is a wall represented by a 4 1/4 inch line on the blueprint? So we need to set that up as a proportion. 1 inch corresponds to 4 feet. So the way we're going to write this is 1 inch is to 4 feet as 4 1/4 inches is to X. Okay. So I want to point out that when you use a proportion to solve an application problem, make sure that you have one set of units on top of both fractions and another set of units on the bottom of both fractions. Okay. There's more than one way to set this up, but generally speaking, if you put one set of units on top, other set of units on the bottom, you're probably setting it up correctly. All right, so now we will cross multiply. Just a second. Okay, mouse went missing there for a second. All right, so 4 times 4 1/4 equals X times 1, or X equals 4 times 4 1/4. So remember from chapter 4, the way that you multiply mixed numbers is to turn them into improper fractions. So I'm going to write 4 as 4 over 1, and I'm going to write 4 1/4 as 17/4. Remember how that works? 4 times 4 is 16. 16 plus 1 is 17. The 4s are going to drop out. And that's going to leave me with X equals 17. And remember what X stood for? It stood for the answer to their question, how long is the wall? This wall is 17 feet long. All right, last example. This is one maybe that you can try. An auto mechanic recommends that 5 ounces of isopropyl alcohol be mixed with a tank full of gas, 16 gallons, to increase the octane of the gasoline for better engine performance. At this rate, how many gallons of gas can be treated with an 8-ounce bottle of alcohol? So think about how to set up your proportion. Pause the video if you need a minute to think about it. So again, we have 2 sets of units. We have ounces of alcohol. So the way that I would read this is 5 ounces is to 16 gallons as 8 ounces is to X. Okay, notice the top numbers are in ounces, the bottom numbers are in gallons. So if we cross multiply, 5 times X gives me 5X. 16 times 8 gives me 128. 5X equals 128. I'm going to divide both sides by 5. And that gives me X equals 128 divided by 5, which is 25 6/10. So the amount that can be treated with an 8-ounce bottle of alcohol is 25 6/10 gallons. And that's the end of section 6.1.